Hello guys, welcome back to STR8CHEM. In this video, we're going to look at how to solve some problems in moles concepts. It's not a very difficult type of problem solving, but sometimes it can get a little tricky for students to understand. So I hope you can pay attention and have a look at these problems. We're going to start with problem number 1. Right here, what you can see is the question wants you to calculate the number of moles. So the question wants you to find the number of moles, yeah? We're gonna try to identify what the question wants first. Over here, I will highlight this. So the question wants you to find the number of moles. So this is what the question wants. So we will find this is what the question wants. Okay, so our mission is to find out how many moles for 3.01 times 10 to the power of 21 molecules of ozone. Molecules of ozone, number of particles right here. Okay, we're going to start right there. So we will begin from the number of molecules of ozone. So our starting point is from no. And we want to move to here to find our mole. And to get there, from number of particles, number of molecules of ozone, we have to take the Avogadro's constant, okay, the number of particles, divide by the Avogadro's constant, then you should be able to get the number of moles of your ozone. It's very simple. So we're going to write down, I'm going to write down the number right here. So you have 3.03.01 times 10 to the power of 21. And that is this. And what is the Avogadro's constant? We have learned about that in the other video. So we're going to divide that with 6.022 times 10 to the power of 23, and you should be able to get, and use green, so we would be able to get the number of, well, if you compute that in your calculator, you should be able to get something like this, 4.99 times 10 to the power of negative 3 mole of ozone. So this is the answer for this question. So in exams, you will get 1 mark for this and 1 mark for your final answer. It's very easy. Moving on to problem number 2. This is a little bit trickier than what you have seen just now. The reason why I said that this is trickier is because you need to work out what is the molar mass for sulfuric acid. Why do you need to do that? Because you're going to start from mass and you're going to move towards the number of moles. And as you can see in the Mamo-Vono intersection here, if you want to move from mass to the number of moles, you have to take into consideration the molar mass of the species that is given to you in a specific question. In this case, we have sulfuric acid. So if you do not know how does sulfuric acid look like, it's going to be a problem. Okay, so sulfuric acid, I think we should be able to work this out. We have seen this before in your secondary school. So for sulfuric acid, this is H2SO4. So in one sulfuric acid molecule, you have 2 hydrogen, 1 sulfur, and 4 oxygen atoms. So before you want to do anything, we need to find out what is the molar mass of sulfuric acid. So let's try to work out the molar mass first. I am going to use, which color I'm going to use? I'm going to use black, okay, ink. So the first thing you need to work out is the molar mass of H2SO4. And how do you do that? So you're going to look at the constants over here. So you can see this, like I said before, this table will be provided for you in exams. So we can see that hydrogen, the relative atomic mass is 1. Okay. If you go back to the life board, 1 hydrogen there. So you'll get 2 because you have 2 hydrogen, and the relative atomic mass is 1. So times 1.0 plus, now we have 1 because you have only 1 sulfur. Okay, so sulfur is, if you go look here, sulfur is 32.1 relative atomic mass. So times 32.1, and you have oxygen. Oxygen is 16. So you have 16. Sorry, I'm just going to write 4 times 16.0. And the molar mass should be, if you do that very quickly on your calculator, you have 4 times 16, you have 98.1 gram per mole. So that is the molar mass that we need for that. Remember, we're going to move from mass to mole because the question wants you to find a number of mole, just like what we have done in problem number 1. So this is what the question wants. Right? So we're going to find this from what is given to you here. So we're going to move from ma to mole. That's why we're going to need the molar mass. And we have the molar mass here. Usually you won't get mark for this, but for the sake of you to remember this step, I'm just going to say that in exams you might going to get 1 mark for working out the molar mass for yourself. Right, so step 2, we're going to proceed with taking the mass that is given to you in the problem, divide that with the molar mass. Okay, so the mass given to you is 24.5 grams, and we will divide that with the molar mass that you have worked out. Divide with 98.1 gram per mole. Then we'll have something 0.249 mole. Okay, so that is the answer for this question. So very easy. So you get 1 mark and another 1. Now let's move on to problem number 3. So this one right now, we're going to start from the molar volume of gas. You can see that the question still wants you to find the same thing. You need to find the number of mole, and what is given to you is the molar volume of gas. And the condition that we need to consider is at STP. So we're going to move from molar volume of gas, and we need to find the number of mole at STP, and we have to take into account 22.4 liter per mole. The volume is 10. We have 10 here. Okay. 10.0 liter. And we're going to divide that with, divide with 22.4 liter per mole. Okay. And after you're calculating that by using a calculator, you would be able to get 0.446 mole of oxygen gas. Okay, so that is the final answer, and you get 1 mark for that one and 1 mark for this. Now, let's try slightly more difficult problems. Okay, so I'm going to challenge you to think about these problems now. So problem number 4, you are required to determine the number of molecules in 25.0 grams of CH4. Determine the number of molecules in this much of CH4. Our starting point will be from mass. If you look carefully, our starting point is from here. So we're going to start from here. Okay. I don't think you can see that. So I'm going to use a different colored pen. So we're going to start from here. Okay. So this is the starting point of this question. And you want to find out this number of particles. So you're going to end here. So how do you do that? As you can see from the Ma-Mo-Vonner intersection, you're going to start here, and before you're going to go there, you're going to stop by in moles. So you're going to take the mass, you divide by the molar mass, you get moles, and then you're going to times with the Avogadro's constant. Then you will be able to find out the number of molecules of CH4. Okay, so you're going to move towards this direction. So let's have a look at step number 1 over here, shall we? Step number 1, I'm going to do that. So first, this is what we have done. Okay, 25.0 grams divided by the molar mass of CH4. How do you get the molar mass? I've shown to you just now in the previous problems. I do not have to show to you that again over here. Okay, so that is the molar mass for that. So when you do that, you should be able to get the number of mole. Now you have reached this point. Okay, so the number of mole is 1.5586. You have reached this point. And to get to where you want to end up based on the question given to you, you have to take this number of mole times with the Avogadro's constant. And we know that Avogadro's constant is 6.022. times times 10 to the power 23 mole. Look, that is exactly the same number that we have worked out just now. And we're going to multiply with the Avogadro's constant based on the Mamo-Vono intersections. Once you have done that, you should be able to get your answers: 9.39 times 10 to the power 23 molecules of CH4. Okay, so you'll get 1 mark for this, you'll get 1 mark for this, and 1 mark for the final answer. Problem number 5. What do we need to do now? We need to determine the number of carbon atoms in 0.50 mole of C2H4. Remember, number of carbon atoms. So you do not get tricked by this situation. First, you need to find out the number of molecules first. Then we would be able to work out the number of carbon atoms inside C2H4. Remember, this is the molecule. Okay, so this is the whole molecule. So inside the molecule, you have 2 carbon atoms. You will see that afterwards. Okay, so we're going to start from, if we look at the question, we're going to start from mole here. Okay, so this is where we're going to start. And we will be going to this direction. Okay, so you're going to times with Avogadro's constant. Therefore, in step 1, 0.50 mole times Avogadro's constant, you'll find the number of molecules first. Some misconceptions or common mistakes that students would do in this kind of questions in exams, they're just going to stop right over here, okay? They're going to stop right over here because they were used to this kind of question in which they were required to find the number of molecules when a certain number of mole is given. We have a number of mole given to you, yes, and you want to find the number of particles. You times with the Avogadro's constant based on the Mamo-Vono intersection. Yes, you're going to get 1 mark. Still, you're going to get 1 mark for this. 1 mark from here and 1 mark for your final answers. But this is not the whole story yet. Why? Because when you look at the question, it wants you to find the number of carbon atoms. So, when you look at the molecule, we can see that, whoops, I'm going to show that again. There we go. When you look at this one molecule, in one single molecule, you have 2 carbon atoms. And the question wants you to find the number of carbon atoms. So in one molecule of C2H4, there are 2 atoms of carbon. I think some of you might have got the idea now. You have to times 2. You have to times 2 here because this is the number of molecules. Number of molecules for 0.50 mole. In one molecule, you have 2 atoms of carbon. So in 3.011 times 10 to the power of 23 molecules, huge number, a lot of molecules of C2H4. How many carbon atoms? Exactly. When you times by 2, you take the number here, the number of molecules, times 2, then you get the number of carbon atoms. This is just the steps to find out how many molecules of C2H4 in 0.50. And to fulfill what the question wants, you need to look back at your molecules, make sure you have got the number of atoms correctly. Carbon atoms, 2 carbon atoms in one molecule of C2H4 times with the number of molecules, then you get the number of atoms. You get 1 mark for this. Okay. Now, problem number 6 is going to be slightly more trickier or difficult if you compare with number 5, but still it's going to be based on the Marmov intersection that we have right there. Now, determine the mass of carbon atoms. Okay, the mass of carbon atoms, 1.0 grams. Okay, we're going to start from mass of the whole thing. The question wants you to find the mass of carbon atoms in here, but we start from the mass of the whole thing. Okay, so this is the mass of the whole molecule. So don't get that confused. Okay, the one given to you here is, okay, so that is the mass for the whole molecule. Molecule. So we need to find mass for carbon atoms. Okay, it's a two different things right there. Step 1. Okay, step 1, we're going to start from the mass, change that into mole first. Okay, mass of your molecule, we change that into mole. So we take that. Okay, so this is just the way for you to find out the molar mass of this whole thing. Okay, I'm gonna try to highlight that so that you can see this is the molar mass for that. And you do know how to work out that already. And you'll get the number of mole. So this is the number of mole for this. Okay, I'm going to highlight that as well. So this is the number of mole for that, this whole thing. So we have done step 1 to find the number of mole for that whole thing. And we're going to change, we're going to find out how many molecules of C20H24N2O2. How do we do that? In step number 2, we'll take the same number. Okay, I take this number times with Avogadro's constant, like what we are doing over here from mole, change the number of particles, and we'll be able to get the number of molecules. Okay, so you have the number of molecules of C2H24N2O2. So far, what we have done is you change that into mole first, you get 1 mark. Okay, you have 1 mark over here as well. And you'll get 1 mark for this step, and you get 1 mark for finding out the number of molecules. But we're not done yet, okay, because we want to find out the mass of carbon atoms. So from here, we will be able to know how many carbon atoms in one molecule of C20H24N2O2. Yes, your guess is exactly right. You're going to times with 20. Okay, you're going to times with 20 and you get the number of carbon atoms. Maybe I'm going to highlight that. Okay, so you have 20 over here because you have 20 over there. And this is just the same number of molecules, and you'll get the atoms. Okay, how many carbon atoms in there? So to find the mass of carbon atoms, we're going to move on to step number 3. So what do we need to do in step number 3? You'll take you're going to take the number of carbon atoms. So this is the number of carbon atoms just now, the one that we have worked out from here. So we take the number of carbon atoms think I'll try to highlight that again. So that is the number of carbon atoms, and you divide with the Avogadro's constant to get the number of moles of carbon. So this is the number of mole of carbon atoms. Okay, number of mole of carbon atoms inside in that molecule. Therefore, in step number 4, you times with the molar mass. So that is the molar mass of carbon atoms. Of carbon. If we look at the value over here, when you look at carbon atoms, where is it? So I'm going to use green. So carbon is right there. Okay. And so you have 12. Okay. So you take the molar mass of carbon times with the number of mole, then you get the mass of carbon atoms. So it's slightly more difficult on the surface of it. You have one mark, you have one mark over here as well, and one mark over here. So that is how you're going to solve some problems in the mole concept.